How do I begin? Always begin with the general equation. What's the general equation for the surface area of a cylinder?
Base times height.
No, that's volume, and it's 1/3. Excuse me. Surface area of a cylinder. Okay, here, let me back up a second. I was thinking cone, but it's okay. Surface area of a cylinder is just as important. Volume is capital B times height. What's surface area?
Base 1 times, or plus base 2 equals, or times height?
Not quite. It's definitely two bases, because this is a prism, so you have the area of this base plus the area of the bottom base. And that's 2 pi r squared, right? Because each one is pi r squared, so there's 2 of them. Now the area of the lateral surface area.
Well, circumference.
What's that?
Circumference times height.
Good, but it's a different height. It's not this h. Oh, yes it is. Excuse me. So it's what in terms of r?
2 pi or h.
Exactly. Okay. Now, that's our general equation for surface area of a cylinder. Now we go in and we start substituting. Well, they give us the surface area is 72 pi, so we'll write that over there. We've got r and h as our variables left. Tells me the cylinder's height is 3 times longer than the radius of its base. So what can I fill in for h? H is no longer h. What is it? It's 3 times longer than the radius.
3r.
Now I have one equation and only one unknown. And actually solves fairly easy. 2 pi r squared plus 6 pi r squared. How many total pi r squared do we have?
8 pi r squared.
I can cancel the pi's. Divide by 8. R equals 3. And what was the question? To solve for
The circumference, or the area.
what does it want? Does it say? No, it doesn't say, does it? Oh, determine the cylinder's height. The very last sentence. I don't know how I missed that. I always go to the last sentence of these word problems first anyway. So if the radius is 3, the height is the radius is 3, the height is
9.
okay. Looks like you had most of it correct. You get to this point right here, and that should give you an R of 3. Just had to take one last step of taking that R of 3 and turning it into an H that's 3 times longer than that. All right, let's look at 15. How do I start? I haven't even read the problem, and I'm still going to start this way.
Oh, I get this one. This one we don't have to do.
Okay.
He didn't teach us the formula for sphere or hemisphere
Okay.
until after this quiz, and he's dumb, so.
Yeah, well, notice that a hemisphere is always half of a sphere.
Yeah.
So it's the half volume, it's half the surface area. Everything about a hemisphere you don't need this formula. You can start with the formula for a sphere and just cut it in half. But okay, so you want to go to 16?
Yeah.
All good. Blow it up. These kind of word problems I don't have any problem with. I think these are perfectly fine and good. The ones I have problem with is where one teacher would grade it differently than another teacher would. In other words, in our last session, the first couple problems we looked at were totally subjective as to how you answered the question. And I object to math that is subjective. If there's anything about math, it's precise. There's nothing subjective about it, and there never should be. It should all be problems. All right, let's see here. Let me read this paragraph. Okay, if you're going to paint something, you have to know what its surface area is, right?
Mm-hmm.
Okay, so I'm painting these pillars, but I don't have to paint the bottom and I don't have to paint the top. In other words, I don't have to paint the circular parts of them. You see why?
Mm-hmm.
Because the beam is resting on top and the pillars are resting on the ground. So there's no point in painting the bottom. Well, determine the surface area to be painted so that it can be determined how much sealant is needed. The circles at the very base are where the pillar enter the ground, so they do not need to be counted. And they're covered by the beam there, so they didn't need to be counted either. Although I would think maybe you'd want to put some water sealant on them. But for this problem, you don't count it. So the only thing we need is the surface area of each of these. Well, the one on the left, one has a diameter of 4 and a height of 2. Well, both of them. So the diameter is 4 and the height is 2. So what's the surface area of one of them?
Mm-hmm.
What's the formula for lateral surface area?
It's a 2 pi r
It's the circumference.
times the height.
Right. I always think of it as a label of a soup can. If you took the label of a soup can off and laid it flat, you'd have a rectangle. And the one measurement would be the height, and the other measurement would be the circumference of the circle, which is 2 pi r. Okay, so since I've got 2 of them, I'm going to multiply that by 2, and just make sure you don't forget that you already multiplied it by 2. You can do these problems in a number of ways. The way I actually prefer to do it is to figure the surface area of one beam, get it, and then multiply by 2. I'm afraid that if I multiply by 2 before, then I might multiply it again and I might make a mistake. So use whatever methodology allows you not to make a mistake. Okay, so we're going to do this. So what's R and what's H?
R is 2. And H is 2.
And they want the surface area, so the only variable we have is the surface area. So 16 pi. by knowing that surface area, and by knowing, this doesn't tell you anything about the paint or anything. No. Let's say that 1 can of paint could paint 8 pi area. Well, then you need 2 cans of sealant to cover these 2 cylinders. So what happened here? How come we missed it?
Was the whole thing.
But was it the
Well, so,
lateral
wait, on the,
surface area? Is that what gave you the problem? Was the lateral surface area?
no, I just did, when I tried to find the, like, the rectangular box, then I forgot to take out the circles.
Okay. Okay.
And then,
Oh, okay, because you got the original base. Okay. Yeah, when you have combination figures like this, and they're talking surface area problems, there's almost always a surface that's covered up. In other words, even if one isn't a cylinder and one is a, if I have some shape like this that's sitting on top of that, and they're three-dimensional figures, well, I don't figure up that surface. That's not a surface area. That's inside. So I have to take that surface away. And almost always when you have multiple figures touching, one of the surfaces needs to be subtracted. So did we cover this problem good enough?
yeah.
It's a little hard for me to tell because, okay, so she wrote this down here. This is your general equation for the surface. No. Who wrote volume? That's not volume. That's surface area.
That's,
Oh, no, that is volume. No, it isn't. No. Volume is area of the base times the height. Surface area is 2 bases, which is that, plus 2 pi r times the height. So that's the correct one, and she crossed out that because neither of those bases should be counted. But she labeled that wrong. That's not volume, that's surface area. Okay. What else? We got 10 minutes. Should we look at D? D's pretty easy. I bet you can do D now. Start with the general equation
surface area of a cylinder.
of a cylinder.
So, pi, 2 pi r plus, times
Pi r squared.
times h.
Well, no, in this one, it's this. In other words, this is both bases. The surface area of both bases. This is the lateral surface area. That's the label of the soup can. Okay? So that's your surface area. It's the same as this formula she wrote here, only she mislabeled the left. She meant to say surface area of the cylinder, not volume of the cylinder.
But that's the surface,
What's that?
why is it times h? Why is it 2?
Because when I take that label off, it looks like a rectangle. And this is h. And this is the circumference of the cylinder. So that's 2 pi r. So the area of that rectangle is 2 pi r times h. You with me?
Okay.
Okay.
Yeah.
Now we still have to go further because they've made it into an algebra problem. But everything is about getting the general equation correct. Okay? Now they tell us the radius is 3 times longer than the height. Determine the height. Well, how am I going to write this? Should I I change radius to height, or should I change h to r?
But then it'd be 2 R's.
Right, and we're trying to solve for h, so let's change the radiuses. Instead of r, let's write it in terms of h. How am I going to write r in terms of h?
Do lowercase h and then uppercase h, right?
No, same h. Same h. There's very few problems where there's two different h's. If you had like a hexagon as the base, that you could say the apothem was h, maybe. I don't know. But in this one, the h is the same. But what is r? R is 3 times longer than the height. So isn't r h plus 3?
Yes.
Okay, I got to square it. Plus 2 pi, instead of r, I'm going to write h plus 3. There we go. And they give us the surface area, 96 pi. Well, there's only one variable in that, h. Now, granted, there's a lot of algebra involved, but all you have to do is expand it, simplify, combine, solve the equation for h, and you'll have your answer. And incidentally, I noticed that you have a pi in your answer. Is that right, or is that 17? Is that a pi?
I think it's a pi.
Linear dimensions almost never have pi in them. Those are always circular dimensions or areas. And notice that these pi's are all going to cancel. That pi, and that pi, I'm going to divide both sides by pi. So pi's just went away. So whatever I come up with for h, not going to have pi in it. And just know that you almost never get pi as a linear dimension. And that's what they're asking for, is the height. You never see a cylinder height in terms of pi. They don't do it that way. Surface area, yeah, surface area can have pi in it because it involves a circular base and a circular top. And in fact, the area of the label of the soup can also is a square area, so that can have pi in it. But a linear dimension almost never does. If you see a pi in your answer, you've made a mistake. What the heck? Again, she puts the wrong formula here. Why is she calling this v? Am I missing something? What's the subscript say? V of what?
Pillar. P-I-L.
Oh. But she's using V. She should be using SA. And that's not even the right equation for SA. The one I've written up here is the right equation. She put only this part of it. It looks like almost what she did was she took this equation, the proper one, she crossed that part out of it because it didn't apply to that problem, but then she used what was left over to apply to this problem, which isn't even correct. Because in this problem, the surface area does include the bottom base and the top base and the lateral part. So it's this whole thing. Now, notice one thing they did here is they had a problem where they said the height was 3 times the radius, and then here's the same problem almost, only they say the radius is 3 times longer than the height. Ah, I did this problem wrong. It's not h plus 3, it's 3h. I forgot to look at the word time. I thought it said the radius is 3 longer than the height, which would have made it h plus 3. But when you include the word times in there, then it's a multiplier. So instead of h plus 3, this should be 3h in both spots. That actually makes the math quite a bit easier anyway. Now you have 96 pi equals 18 pi h squared plus 6 pi h squared. Now I have 96 pi. So if I have 18 pi h squared and 6 pi h squared, I got 24 pi h squared. Now I cancel the pi's, divide, you got 4 equals h squared. H squared. Once you get the starting general equation, the only way you're making a mistake is to make an arithmetic mistake. That is the secret of geometry, I'm telling you. Every one of these problems that I'm looking at here, I would have liked to have seen you, the very first thing you wrote was the general equation. In other words, everything that she's writing here should be your first line, only written correctly. All right?
Okay.
I will talk to you, what do we say, tomorrow? Yeah, tomorrow and when? All right, have
Okay.
a good one. Bye-bye.
You too. Bye.